Welcome back, guys. Today we're going to focus on this. We are going to build ourselves a portable smaller 48 volt battery bank. Before we start, we need to make a couple of considerations on this battery bank. We need to know, first of all, how many cells do we have. In my case I have roughly 180. My cell's capacity is around 1700 to 1950 milliamp hours. As I said, I'm going to design this as a 48 volt system. The next thing we need to consider is how much amperage can we have out of this pack. In general, when we are talking about used laptop batteries, I do not recommend to go above 1 amp. If you stay below 1 amp, most laptop batteries will be able to cope this. Even though you could go to 2 to 4 amp if needed. But we are going to calculate it based on 1 amp. I'm using a 14S system. That gives us 14 times 3.7 volts. That's the nominal voltage. Now we know that we are going to use 14 strings, and we also know that we have 180 cells available. Next thing that we need to take a look at is how do we set this pack up. I'm using this sort of system to sort my packs, and that means I need to have them in range of 20, 20, 20, 20. I'm going to do this in a way where I have 20, 20, 20, 20, and we do the same up there. That's 2, 4, 6, 8, 10, 12, 14, 16. That gives me 160 cells. So if I going to add 20 more, they will be uneven. So I'm actually going to stay with the number 160 cells. Next thing is 160 split by 14. That would give us 11.4 cells per string. And of course you cannot split the cells. So I'm going to give us 11 cells per string. And that would give us 14S11P. Let's take a look at how much we can pull out of this pack. If we're going to calculate it with 11P, that's 11 times 51.8 volts. So we actually 11 amps, since I am calculating based on 1 amp. That says that we are not going to go above 569 watts out of this pack. Let's say we are calculating based on 4 amps instead. That means 4 times 11 times 51.8. That would give us roughly 2.27 kilowatts instead. So we are safe there. What kind of wire are we going to use? What kind of fuses are we going to use in this pack? The fuses I'm going to use here are based on 35 AWG, and they are rated for roughly 5 amps. Actually they blows between 6 and 12 amps instead, depending on the length, of course. If I'm going for 11 amp only, I would be fine with 1.5 millimeter in square, but I'm not going to go that route. Let's say I go up one step, 2.5 millimeter square. That would potentially give me, note that I'm excluding the part when it comes to calculating internal resistance and everything like that. We're doing it very, very generalized. And in my world, 2.5 square millimeters can handle up to roughly 16 to 20 amps. I'm calculating 16 amps. And to make this very, very good here, I'm actually going to have 2 times 2.5 square millimeter. That gives us a maximum of 32 amps. Even though we could potentially pull 4 amps, those cables will be able to handle that easily. This is just based on the voltage drop, and we're using general simple rules. So now we know that the wires we're going to use will be 2 times 2.5 square millimeters. The fuse wire will be the 35 AWG wire, and we know that we are going to use 14S11P system, so that's basically all we need. Last thing, we need to connect this up to something, and in my case I'm going to use a connector called XT, and I'm going to use this one here. This is XT90. It's actually rated for 90 amp continuous. And before we build the packs, we had one more thing to talk about. How many watt hours would we get out of this pack? And that's pretty simple. We calculate based on the lowest number. We know that we have 1.7 amp hours in the cells. We know that we have 11 of them. That would give us roughly 18.7 amp hours per pack. To get the watt hours per pack, we take 18.7 times 3.7. That would give us 69.19, and this is watt hours. Now if we multiply that 69.19 with the number of packs in series, we know that we have 14. That gives us 968 watt hours. So almost 1 kilowatt hours will be in this pack. And that's pretty good, I would say. I have all the cells totally mixed up here, and that's how I want it. First of all, we're going to start in one end and end up in the next one. We know that we are going to use roughly 11 of them. So we start to add 11. I'm going to use them in 2 strings. So I'm putting in 11 here. And notice that I end on that side. Let's take 11 more. 2, 4, 6, 8, 10, 11. 2, 4, 6, 8, 10, 11. That's the first 2 strings. So let's continue, and I will show you the rest afterwards. It's a little bit trickier in the curve here, but you just continue on the other side. So that's the first thing. Now it's time to add the top on. And this is can be a little bit tricky. You may want to add them in smaller pieces. Sometimes it though works fine to do it like this. Sometimes it doesn't. Then you have to fiddle a little bit with the cells. But generally it goes pretty good. It's important to cross-check that you have them all in row, because if you don't, it's a hassle to get them right. And as you can see in this end, I have this hole here now, and that's the missing 6. That's totally fine for my part. I could have filled them in with some random cells and try to get it even, but I'm going to have the contacts inside here, so that's fine. And as you may see, the cells are not properly aligned, so it's just a matter of gently tapping them down, and just a matter of cross-checking that I do line up properly. And then you cross-check the other side as well, and that looks fine. As you saw on my chart before, I'm going to use 2.5 square millimeter wire times 2, and here you have it. I have twisted it around each other because it's a lot easier to handle. So basically, we are going to have the contacts on the other side because we are starting in the edge here. So this is rather important, because you're going to connect the negatives on that pack to the positives on this one. So it's just a matter of laying on top like this, and you cut it off. Then you take your next piece, and that one will be tied like this, except for when you get to the edge here, you need to bend that edge before, like that, and that edge need to go all the way up to this point. So let's start with this one and fuse that one up. And that's the first strand. And now it's time for the next one. I have already one pre-made here, and it's just a matter of finding the start and the end. You have start here, 10, 2, 4, 6, 8, 10, 11. And then you have another 10, 2, 4, 6, 10, 8, 10, 11. So we need it between that one and that one over there. And now you wonder why there are no connection in between here. That's because we are going to connect those two on the other side next time. So what we are doing, we are tightening this with that one with that one, that one with that one, and we get output on that, minus and plus. As you can see, the top layer is now done. It's pretty simple, it's just getting in there. I can see that I got that one a little bit not really good, because those fuses get a little bit short. Anyways, the other side is a little bit more complicated, because now you need to start to think. First of all, you cannot connect like we did here. You need to connect that one first, and then you start to connect all over. So let's turn this around. One. This side is a little bit more complicated because we need to start to think now. The problem here is that we have live connections between them, and we can short circuit stuff. And we still know that we are transferring the power in this way around, all the way around like that. So we have the bottom cells here, this is the minus, and then we suddenly go over to positive here. And if we measure between those, we will see that we have 8.25 volt. And that's the thing here about this. We cannot connect those cells here with those there. This is a single line. So let's start working on it. So when you are doing this, make sure that you aren't putting this down on top of it, because you will get big sparks. So let's start with this one, and we know that we are going down to that cell. And this one I also want to go out, because we are going to connect the outgoing part here. So I'm actually going to cut this a little bit longer. This one should be connected roughly like that. And then we get this one down. Something like that. So this is basically the first one, so let's add some wires to it. On this side I'm not going to use the fuse wire, but the thicker ones instead. So it's very, very important that you never short circuit anything here. So let's add this up first. And that's the first string. So let's go ahead with the second one. First of all, we need to connect that one over there, and we're going all the way down there and all the way for another 11 ones. To do this we need roughly that length, and we need roughly the same on the downside here. Start by twisting this end, and that one will be laid like that, and we do the same on the lower end here, and that should be it. Now it's a matter of taking the next one, and this one is a little bit more complicated. I do want to bend in that end, like that, and then I want to bend this one like here, and then I also want to go next level and bend this one there. And now it's a matter of finding the end, and the end is right here. Something like that. And this is how you continue all the pack around. So let me solder this one up, and then I will continue my own. And then we bend it down in the hole. That should be it. Let's solder this last piece together. There we go. 57.7 volt. That's good. This is the side here where we have those two leads. The positive is there and the negative is there. So what I want to do is add a fuse. Since the cells are rated for 11 amp and they are able to actually cope with higher, the cable is rated to be handled 30 amp easily, so I will also be fusing it with 30 amp. The cable I'm going to use for this is 6 square millimeter cable, and the same cable that I use for my solar panels. I do not have anything else. You need to peel back some of this. And when it comes to hooking up the batteries, which one of those should you use for the battery? If we take a battery here, a lithium ion battery or lithium polymer, you will see that this is the end used for the battery, and I will be doing the same thing, this one here. Soldering iron is a little bit too big for this kind of work, but it works. And that's kind of it. Now you have a nice looking cable for it. So now it's just a matter of adding this up into the battery. First of all, we take this one, if we can get it out, like that. And since I do want to have this connected here, I will cut this off a little bit. This one will fit very nicely on top of this, and it fits inside like that. So that's very simple to get it fused. The cable will go in here, and around and down. So now we need to cut that up and make sure that we fit it nicely. And of course, I added a zip tie on that one there, one zip tie and one zip tie there. So this one will end up like so, and this one some shrink wrap around it, because I need to be able to solder that one in place as well. And then I need another shrink wrap above that. This is not really for holding it in place. Just a minor secure. So with this, I want to say thank you all for watching, and hopefully you liked this video. If so, give me a thumbs up. Otherwise, I thank you for this time, and if you have any questions, I will be very glad to answer them down below. Thank you guys for watching another one of my exciting episodes. Don't forget to like the video and subscribe to my channel. Meanwhile, also check out my other exciting videos. And if you want to support my work, you can find links to both Patreon and PayPal below. By becoming a Patreon supporter, you help me a lot and you also gain access to some extra material.